I'm Peter Becker, Group Product Manager for Imagery at Esri, and I'm joined today by Randall Robello, a product engineer for the Imagery Workflows team, who I've had the pleasure to work with for over 20 years. This demo theatre will be on ArcGIS imagery workflows for optimizing image management and services in the cloud. The aim of this demo theatre is to provide an overview of the image management workflows and the associated resources, which include scripts and best practices for automating the creation and processing and configuring of Mosaic datasets. We will also cover briefly how to manage and optimize your data, as well as publishing to ArcGIS Enterprise and ArcGIS Image for ArcGIS Online. The main website I want you to make aware of is ArcGIS Imagery Workflows. The short URL is given below, simply esriurl.com/imageryworkflows. This website provides a wealth of information and best practices for all aspects of working with imagery and automation of many processes that can be scripted as geoprocessing tools as well as web applications. It is split into 5 sections corresponding to the 5 key imagery capabilities. For each section, there is a searchable gallery of workflows as well as corresponding best practice documents, Python geoprocessing tools, videos, tutorials, and helpful links, as well as sample data and sample web applications. For nearly all the workflows, the code is nearly all open, and you can use it directly, modify it to best fit your needs, use it as examples, or as the base for other developments. The sections include how to manage imagery and make it accessible, map production from imagery, which relates to the creation of authoritative content, such as terrain models and orthomosaics from drones, planes, and satellites, analysis, which are the workflows for analyzing imagery and rasters to extract information, including deep learning. Visualization exploitation, which covers many aspects of how to interact with imagery and create appropriate web applications. And content, which focuses on the availability of different content within the ArcGIS system. In this demo theatre, we hope to be able to give you a small sample of the tools that are available to you and provide the right direction towards managing your imagery and raster data, especially for cloud implementations. Before getting into more details on these workflows, let me lay the foundation on the different ways in which imagery can be managed in ArcGIS and explain where these different workflows fit in. Most image management in ArcGIS is done using ArcGIS Pro, which provides the advanced tools and interfaces for managing collections of imagery. Predominantly Mosaic datasets are used, which provide the optimum data model. Mosaic datasets are created to reference the imagery and define not only the metadata about each image, but also define the processing to be performed to convert the imagery into the required products. The imagery in rasters can be simple sets of orthorectified tiles, but it can also be more complex data directly from sensors, multidimensional data, elevation data, or categorical data. The creation of Mosaic datasets is therefore a very important step, and hence the emphasis of many of these workflows. To automate the creation of Mosaic datasets, we recommend to use the Mosaic Dataset Configuration Scripts, or MDCS for short. I'll come back to these soon. The interpretation of the metadata from the source is done using a raster type. If you have a specific sensor or data structure that is not already supported by ArcGIS, then you can create Python raster types to configure this. Once you have a Mosaic dataset, the data can be easily viewed and analyzed in ArcGIS Pro, and typically this is where quality control is performed and changes made if required without modifying any of the source data. If you're creating a base map image, then in many cases you may just want to serve this data as tile cache in ArcGIS Online or ArcGIS Enterprise. Tile cache is similar to what you see in world imagery base maps. The imagery is cut up into large numbers of small tiles and can be streamed very efficiently over the web to client applications that display them as background imagery. There are geoprocessing tools to generate this in ArcGIS, but we would recommend to use the workflows for serving cached imagery, and we will show you this soon. An alternative is to serve the imagery as image services through ArcGIS Image Server for ArcGIS Enterprise. Image Server has been available for over a decade and focuses on serving dynamic imagery where clients make requests and the server performs the processing and returns the required imagery. In recent years, we've added tiled imagery to stream the source pixel values to client applications, image analysis, or sometimes referred to as raster analytics, to perform scalable analysis on large datasets, orthomapping to generate map products from sensor data, and hosted imagery. Hosted imagery enables a different form of image management. Instead of the curator in an organization collecting together all the imagery and then serving it, each user in the organization can individually upload and share imagery, which can then be shared as dynamic imagery or tiled imagery. At the end of March, we will be releasing ArcGIS Image for ArcGIS Online. This will be a new extension to ArcGIS Online to enable the hosting of imagery and rasters within ArcGIS Online. This will provide tiled imagery, and later we will also be enabling dynamic imagery. Image analysis capabilities will also enable the extraction of information from imagery at scale. We will briefly show you how to use hosted imagery and also how to publish and share imagery programmatically. At the end of March, we will also be releasing ArcGIS Image Dedicated. This is similar to ArcGIS Image for ArcGIS Online, but does not provide the image hosting. Instead, it is designed for organizations that have large volumes of imagery and rasters already in the cloud and wish to serve this data without the need to set up their own infrastructure. The workflows for this are the same as those for working in ArcGIS Pro, with the exception that a separate set of tools is used for publishing. Once the imagery is served, you may want to create an application to enable imagery discovery, which is where the Imagery Discovery app may come in handy. There are many other ways to access the imagery, including configurable applications that require no programming, WABIS, which are imagery widgets for Web App Builder, or you may want to reuse some of the sample apps, the code for which is also available. So let's get started with image management, which is the largest section. The image management workflows provide best practice workflows for managing and serving a wide range of imagery types, including pre-processed ortho mosaics, drone imagery, elevation, lidar, multidimensional data, high and medium resolution satellite imagery, as well as imagery from aerial survey cameras, and much, much more. They're all based on Mosaic datasets, and the automation is achieved using MDCS. If using the ArcGIS Pro user interface or standard GP tools, you would typically chain together the following sets of tools. First, create a geodatabase, then create a Mosaic dataset, add the rasters to the Mosaic dataset, build footprints, build boundary, and then share and publish. There are many other tools, and their use will vary on the type of data, and each tool defines different parameters. There are actually over 150 different parameters and environmental variables that can be set. To make a workflow repeatable, you will want to chain these tools and parameters together. You could do this using Model Builder or build your own Python scripts, but there is a simpler method. MDCS is a set of Python-based scripts to simplify the automation for creating and publishing Mosaic datasets. MDCS calls the same GP tools, but provides a way of creating templates that encompasses a list of all the tools to be run, their order, and the parameters required. In this way, they provide a great way to implement and document workflows. The order of the commands and their parameters are stored in a single XML file that makes understanding and documenting the flow easy and very maintainable. In this way, workflows can be easily implemented, modified if required, and run multiple times on different datasets or configured quickly for new projects. MDCS configuration files are easy to transfer to different users and are maintainable between different versions of ArcGIS. As mentioned, the MDCS scripts are driven by XML files. These define different commands that correspond to geoprocessing tools and define the required parameters. Each command is given a short code. The sequence of required commands is then given by a list of these codes. It's very simple, yet very effective, as one can easily understand all the commands called and their parameters, while hiding all the other code that manages the execution. This is an example for how build footprints in Python is defined as an ordered list. In MDCS, it is an XML with key values. You might notice there is a slight difference in the list of parameters between Python and MDCS. The list of parameters shown in Python is from the latest version of the GP tool. The MDCS script was written with an older version of the GP tools. The beauty of MDCS is that it will work with the new or older versions of Python. MDCS can be used to manage data on ArcGIS Pro, or can be run on ArcGIS Server for fully automated workflows. Most of the largest image services being served, such as the Landsat and Sentinel services, are all automated using MDCS. To create an automated workflow, you can take one of the existing samples and just modify the XML to work with your own data. MDCS also includes the scripts to publish Mosaic datasets as dynamic or tiled imagery services to ArcGIS Image Server for ArcGIS Enterprise or standalone image server. You can write your own custom commands to be added to a workflow. MDCS is freely available on GitHub, and you can fork, pull, or push your own changes or submit issues. So let's have a look at a demo for using MDCS. Over to you, Randall.
In this demo, I'm going to show you how to create a Mosaic dataset using MDCS. As you just heard, MDCS is basically a string of commands that you can call to perform a workflow. So let's consider creating a Mosaic dataset, a workflow. First thing I'd like to show you is the XML file that I'm going to use. In this XML file, you can see I've already populated a lot of the values or the parameters, but I've decided that I no longer want to add fields and I don't want to calculate any values in those fields. So it's as simple as coming up here to the list of commands and taking off add fields and taking off calculate values. Then I save this. The next thing is I've created a very simple Python script. In this Python script, you can see I'm going to be calling MDCS. So the first thing I do is I define my path where MDCS is, and then I import it into my script. And then I define the arguments that I want to pass, which in this case is the config file name and the output geodatabase and Mosaic dataset that I want to create. I save this. And using a batch file, I'm going to run this script. You can see the steps. It's adding rasters, building the boundary, setting the Mosaic dataset properties, calculating the cell size, defining the overviews, now building the overviews, which is the last step. And there you have it. It's done. Let's have a look at this Mosaic dataset now. There you go.
I had mentioned before the value of raster types that ingest the metadata and define processing dependent on the input. If you want to create your own, you can use the Python raster types. They consist of 3 parts: a raster type factory, builder, and crawler. There exists a library of samples in GitHub and specific help, so if you are interested in this, do check out the URLs. So, I'll move on to serving cached imagery. If the data in your Mosaic dataset is a static set of images that form an imagery base map, then you may want to just convert it into tile cached and host it on ArcGIS Online or ArcGIS Enterprise. A recommended way to do this is to use the Serving Cached Imagery workflow and associated raster tile cache tools. The tools also provide control over the resolution at which the images are generated and scales at which they are turned on or off, enabling you to zoom in further than with the standard tools. This workflow is also very good for creating an imagery base map that you can then append to and modify over time. The scripts are open, so you can take a look at them and extract the parts to create your own automated tools. So let's have a look at this. Back to you, Randall.
I'd like to show you a short demo on creating raster tile cache from Mosaic dataset. In this demo, I will show you how to create a tile cache using a custom GP tool and publish it to ArcGIS Online. After that, I will show you how you can use a Python script to update your published tile cache. So first of all, this is a Mosaic dataset that I have, which has got 2 images. As you can see, if I zoom in, the images show up. I also have a second Mosaic dataset, which I'm going to use to update with. This has got 3 tiles. Right. So let's begin. So this custom GP tool that we have is called the Raster Tile Cache Tools. It's a Python toolbox. The first step I'm going to do is I'm going to create a raster tile cache. So for my input, I will select the first Mosaic dataset. I'll select my cache output folder. I'll give it the same name as the input Mosaic dataset. And everything else I'll leave as default because this has been calculated by the program. And now I'll just click on run. Right, so that's done. The next step I'm going to do is I am going to package and publish this tile cache. So I'll go ahead and select my cache that I just created. And I'm going to select an output folder to where I can put the tile package. I'm going to give it the same name. And I'm going to select upload online. I'm just going to enter in some of these details which are required for online. I'll make this public and I'm going to host the layer. So let's go ahead and run that. So while that is running, let me just show you the script that I'm going to run. So this is the same script. As you can see, I will be importing the toolbox, which I mentioned earlier. From that, I will then fill in all the same parameters which go into the GP tool. So this is the Mosaic dataset with the updated tiles. This is what I want to call the output cache. And these are my levels. And then after that, I'm going to package the same thing and I'm going to upload it. So I filled in all the details. It's a cache demo, etc., etc. So this is now complete. As you can see, it was successfully shared. I'll just show it to you over here. Portal. My cache. So now the next thing I'm going to do is I'm going to update this cache with the tiles from my updated Mosaic dataset. But this time I'm going to do it using a script. So in the interest of time, I'm going to run this as a batch file, which so there you go. It has created the cache and it has successfully published it as well. So let's go back into ArcGIS Pro and refresh this. So you can see I've got the updated tiles in a separate cache and I've got the original tiles in a separate cache. Now I'm going to merge these two, and this also I'm going to use a script for it. So here is another part of this toolbox, the update tile cache. So cal D1, updated with SoCal_update. Run this match file. That's completed. So let's go back here, refresh, load up SoCal D1.
I mentioned that we will be releasing ArcGIS image for ArcGIS Online at the end of March. Let's have a look at the web interfaces that enable hosting and publishing tiled imagery directly from a web browser.
So the first thing we need to do is sign in. Next step is go to Content, click on Create, Imagery layer. As you can see, it's tiled imagery layer. It's already selected. For this demo, I'm going to show you how to upload one image. Look at the properties, generic source type, compression. I can choose JPEG or LOOK, and I can give the kind of compression factor I would like. In this case, I'm going to choose JPEG, 80% compression, and give some metadata like, say, acquisition date. I'll give it today's date. You can define the measure in unit. In this case, the distance is in meters. I'm going to apply this. Next, I'm going to pick my image. So I'll select this TIFF file, click open. As you can see, it's been uploaded. Click on next. Give it a title. Hosted imagery demo. Just demo. And I'm going to save it. I can choose a folder that I would like to save it in, or let it go to my root folder, and I create right now it's creating a tile imagery layer. Once it's done, you click on done. You can now see it over here in your content. Click on that. All the details that you put in. So if we go to ArcGIS Pro, portal, you can see it here. Just drag and drop it into your view. There you have it.
Well, what if you wanted to do this programmatically? This can be done using a simple API. There are 3 steps. First, you create a token with your username and password by using generate token. There's not much to that, except providing your username and password and the appropriate referrer URL. This will create a SAS connection string. With this string, you can choose any Azure Blob Storage API or app to upload your images. For example, use the Azure Python Storage API. Once uploaded, you will need to create a list of the uploaded URLs and give these as input to the copy_raster service tool. You will need to specify the tiles only keyword in the output name parameter. In the example provided, the copy_raster will create the tiled imagery layer with the name specified and mosaic the uploaded images into a single tiled imagery. All the conversion and optimization of the data is handled with ArcGIS Online. What if instead you have a very large collection of images and need to convert them to an optimal format for serving either in ArcGIS Enterprise or the cloud? A tool called OptimizeRasters is provided for this. OptimizeRasters is a set of Python-based geoprocessing tools that convert and compress raster datasets so that they work much more efficiently, especially when working on cloud storage. It provides a simplified user interface, but can also be scripted. In addition to format conversion and compression, It can simultaneously also transfer data to cloud storage. It is designed to work on large collections of imagery. For further optimizing workflows within the cloud, it can also create raster proxies, which are references to rasters stored on cloud storage, but enable much more efficient access and speed when creating Mosaic datasets for very large collections. OptimizeRasters is provided as 3 geoprocessing tools. OptimizeRasters is the primary tool and does the conversion and upload. Profile Editor enables setting up cloud profiles that enable the required security access. Resume Jobs is the tool that can retry images that fail to transfer correctly. When working with large numbers of images in the cloud, things do sometimes fail, and OptimizeRasters retries, but eventually adds the issues to a file that can be retried at a later time using the Resume Jobs. In addition to providing a UI within ArcGIS Pro, it also supports command line operations by batch files or Python scripts. Similar to MDCS, it is controlled through an XML parameter file that provides a form of configuration template that defines the conversion and compression parameters, input and output locations, and many other parameters that can be set depending on the format of the data being created. Again, the code is open and is all available in GitHub. Just go to GitHub and search for OptimizeRasters, or see the URL below. The Imagery Workflows website also provides links to a range of tools to aid in the development of web applications. This includes Image Services Catalog widget that enables a search and discovery experience across multiple image services and can also enable the creation of carts to provide references to images that can be used for clip, zip, and ship type applications. WABIS, which is a set of imagery widgets for Web Application Builder. Configuration templates that enable the creation of applications with no coding. They include a general imagery viewing application, as well as more specific applications, such as a visit application to enable quality control of imagery and the review of many locations. There is also a change detection application. There are a number of imagery apps that have also been created where all the source code is available. The simplest way to see these apps is to go to the Unlock Earth Secrets page, but follow the links to get access to all the code that can be used to quickly create similar applications. Another set of tools that is also available from the Imagery Workflows website is related to oriented imagery. Oriented imagery refers to working with the massive volumes of imagery that are being collected but are not nadir or top-down imagery typically used in GIS applications. This includes inspection imagery, street view, oblique imagery from drones and planes, 360 imagery, but also panoramas and videos often collected from terrestrial vehicles. Oriented imagery includes tools to create the oriented imagery catalogs. These reference the often large collections of imagery from different sources, often stored directly in cloud storage, along with metadata required to provide the orientation. There is a separate Introduction to Oriented Imagery demo theater that I recommend you check out. Similar to the Python raster tools used to read metadata and add imagery to Mosaic datasets, there are similar Python image types used to read metadata about oriented imagery and create the oriented imagery catalogs. These can be developed to support new sensor sources. That brings us to the end of this session. I hope you have found it interesting and that has given you more details on the many different workflows for optimizing image management and services in the cloud. The simplest way to get access to the resources is to follow the links from this presentation, but also check out the extensive resources in the Imagery Workflows website. With that, we will take our leave. Please do provide feedback for the session by clicking on the survey link directly below this video. Thanks for listening, and goodbye.